Hi everyone, welcome back. Last time we used our regression coefficients A, B and C to make a prediction, an accurate prediction, based on a target percentage of 60%. Now the nice thing about using Excel formulas to do this, apart from the higher accuracy, is that I could change that to a 50% target and it recalculates for me automatically. No additional effort needed. So that's an advantage of using Excel. Oops, that didn't work. Because 70 is too high. We were never that high. So we'll go back to 60 the way we were. If I try 65, I get a reasonable answer there. 65% is coming in here somewhere around 2023. So that's working nicely. I'll put that back to where I was. Now, the question arises, we've got a good model, we're happy with the residual plot, we think that the quadratic is doing an accurate prediction, but how accurate is that prediction? That's the question. So let's just readjust the view we're seeing here for a moment. I will go back and format that to include no extra predictions. That's just so that I can rescale my graph and see what's going on here a bit more accurately. Now you notice that the error bars we had there. Well, those error bars as not just there for decoration. If I wanted to do a worst case model rather than a best case model, the worst my model would be is if the actual measured data point was at the lowest point of these three error bars, but at the highest point of those three error bars. That would give me a much more extreme model. And it would push my prediction a lot further out. I would have a graph that is not curving as steeply as this one, so my future prediction would go further away. I'm going to call this my maximum model. Now, how would I get my maximum model? Like I said, I would need to, for the first three data points, I would need to have the lowest value. I would need to have the measurement minus the uncertainty for the first three. For the next three, I would need to have the measurement plus the uncertainty. There they are. Now, I will just add that to my model just for a moment so I can have a look at what's going on. If I go to Chart Design, select Data, then I can add a data series. My X values will be the years. My Y values will be these new set of Y values I've calculated out. And there they are. You can see those data points are completely different to the original data points. They're at the extreme lower end of the error bars for the first half and the extreme upper end of the error bars for the second half. Now, I can go ahead and make predictions and models based on those data points as if they are my Y values. I've shown you how to do all this before, so I'll pause for a moment while I do that. All right, welcome back. So what I've done is I've used a regression model. I have used this set of numbers here as my Y values instead of the original data points. I've still used both the time and the time squareds, so I've produced a quadratic model. These are the values of the coefficients A, B, and C. They're close to, but not exactly the same as the previous ones. You can see the value of C is a little different, the value of B is slightly different, and the value of A is a little bit different. If I go to more details, you'll see some differences. I've then done the same target, 60, and the same prediction. I've repeated that formula that I had over there. It was literally a cut and paste job because all those others are still lined up. I then added in, just so we can visualize what's going on, I've added in a automatic trend line here on these orange data points, which that orange curve would be represented by this model, which I'm calling maximum. You see that it's made a different prediction to the one I had earlier. What I think is my best prediction is about 3/4 of the way through, and this one is now pushed out halfway through 2032. So you can see it does make a bit of a difference as to the predictive power. Now that's if I'm used one extreme set of data points. The question now is what happens if I use the opposite? What happens if I use the highest values for this first three set of data points and the lowest possible values for this set of data points? Well, I'll pause once again while I add those in. Okay, welcome back. So you can see now I've added in an extra column for Y values, which I've now called minimum. This time I've used these yellow dots. So the first three data points in this series are going to be the largest possible answers for these Y coordinates, and the next three are the lowest possible. You can see we get quite a different looking trend line here as well, don't you? Again, I did a regression analysis, and then I've got the coefficients A, B, and C, again, close but not exactly the same, and you can see they make a different prediction again. My prediction is now towards the end of 2031. So, as you'd expect, the maximum and minimum predictions are beyond this one. That's fine. If I were to visualize this with my original graph, I could go back. You remember we select the trend line, then we go format the trend line. Now I'm on my original one. I'll predict forward by 10 years on that one. Now if I use, it's a bit hard to click on them now that it's shrunk down. If I click onto my second trend line equation, I can predict that one forward by 10 years. And if I go to my third trend line, I can make that one go forward by 10 years as well. So now I'm going to see on my graph what my calculations are showing me. As these project forwards, they get further apart. My value of 60 is here. So you can see, oh, actually I needed to project that one forward a bit further, didn't I? That top one isn't far enough yet. We can see the numbers here though. That's the important part. The numbers from our calculations are much better than reading from a graph. In fact, the graph is a visual representation that we would include in our report, but we would always use these calculations. So how are we going to summarize these results? Well, we're still going to report this one as our best answer, but we can talk about the level of uncertainty now. We can say that it could be as great as 2032.6, or it could be as small as 2030.95. Now this gives us an estimate for our target with a relative, with a plus or minus, an uncertainty value. And so this is really the best model, the quadratic model, and we're not just giving a prediction, but we're giving a prediction with a relative level of uncertainty involved as well. How would we report that? Well, I would do a calculation like this. I would find the largest one here, and I would subtract the smallest one, and then I would divide by 2. I would say that that's our best prediction, give or take 0.8 of a year. And that's the way I would report that when I was doing my work. So that's the concluding video in our series. We've done quite a detailed analysis here, and we've seen many different ways of doing this. Some at a higher level of analysis and some using the automatic predictive features, but at the expense of less detail. All right, thanks for watching.